Hi, and welcome to this CodeClass curriculum special. This one is going to be on animation. So this one's going to be probably the hardest lesson that you will learn through CodeClass because this is something that a lot of people struggle with. But I think that you'll be able to do it pretty easily with Khan Academy's platform. It's a really great way to learn animation, and it's really cool. So you can see the animation slide right here. So it simply says use the code draw equals function, which I'll show you in a minute, and it will autocomplete into a program. And so basically I'll run you through this because it's easier to see than just to hear about. But what animation is it's a repeating of a frame every microsecond. So basically I'm going to just type out draw equals function, and I'm just going to create a simple function just so that you can see what animation is, and I'll explain it in a minute. So I'm just going to create a background, and I'll explain why I do that in a minute. Oops, I don't know why this is weird. There we go. Okay, so if you see this car going across the screen, you can see that every second it's a little bit farther, or every microsecond it's getting a little bit farther. That's because every microsecond this screen is redrawing itself. So this whole program right here, this draw equals function, this is redrawing itself every microsecond. And every microsecond x, this x coordinate, is increasing by 1. So if we go to the very beginning of this program, the var x equals 0, before the function part even starts, we're simply setting a variable x equal to 0. This is a little bit difficult to teach elementary schoolers because they don't really know what variables are yet, and they don't really grasp this. So the way that I like to fix this is I like to have them call the variable their name. So my name's Lauren. So I'm just going to call it Lauren. And I'm going to change all my variables to Lauren. So you can see it works exactly the same way because you can call your variable anything. So if you have them call it their name, for some reason they seem to grasp onto this better than a variable named x, which an algebra student might understand a little bit better. So I'm going to keep it with my name for a little while, just so that we're getting into the mindset of that elementary schooler. So now getting to the actual function part. This is the part that's probably the most difficult to understand, is this draw equals function. Basically, when you get into more complicated levels of computer science, this would represent a method, and this would represent this reprinting itself every few microseconds. But on Khan Academy's platform, they make it super easy for us that we can literally just type draw equals, and it will autocomplete for us. So if you want to try that, draw equals, and see it autocomplete, you absolutely can. I would pause the video and try that right now. Then the first thing that we need inside of this draw equals function is a background, because we want our screen to be reprinting every few seconds, and it can't really reprint without this background here. So you can see, if I take this out and I restart it, you can see that the rectangles are staying on the screen because this outline is staying on the screen, which we don't want. So then we just see this long trail of things. So we definitely want a background there so that when it reprints, it's reprinting the background and it's not just reprinting our rectangle over and over again. Okay, now the next thing is our actual rectangle itself. So we can see here rect, and then we have our different variables. So if you remember, the first variable of the rectangle is the x-coordinate. So if we look here, our x-coordinate starts at 0 because our variable starts at 0. And then the x-coordinate is increasing, which is why it's moving across the screen. Our y-coordinate is staying at 30 because 30 is never incremented. Now, if we were to change this to Lauren instead, we can see what our rectangle would do. It's incrementing both the x and the y, which is why it's moving in a diagonal instead. I'm going to change this back to 30. Okay, now if we're looking at our last two coordinates, the width and the height, we can also change the width and the height to become a variable. So you can see as it's progressing, it's getting bigger, and that's because the variable is increasing. And our last thing is our height. So if I change this also, you can see the height's also getting larger, as well as the width, as well as moving to the side. So there are a lot of things that are affected by this variable if you let it be. Now let's actually get to the variable itself. So I told you that every time this program is rerunning, this function is rerunning. So every few microseconds, this function is rerunning. That means that anything in here is being reprinted. That also means that every time the function is running, this is getting incremented. So because I said Lauren plus plus is just another way of saying Lauren equals Lauren plus 1, which means if Lauren is equal to 0, every time the program reruns, Lauren equals whatever Lauren is, so in this case 0, plus 1. So the first time Lauren equals 0, then the next time Lauren equals 1, the next time it equals 2, and that continues on every microsecond until eventually this x-coordinate, whatever your variable is standing for, it's going to equal 200, or it's going to equal 400, and it's going to go off of the screen. So now we're going to try not just looking at this little rectangle, but we're going to try actually looking at something that your kids might be interested in implementing in their program. So I just drew out this simple couple shapes right here, and you can see it looks like a rough car. So it's white, it's not super exciting, but it looks like a car. So right now, if I restart the program, nothing is going to happen to the car. And that's because the car isn't being affected by any variables. We have this variable Lauren here, but you don't see Lauren anywhere in any of the variables in the car. So if I want to try first incrementing my rectangle, so if I want to try making my rectangle move across the screen, I'm going to add Lauren to my x-coordinate right here, 20 plus Lauren. So right now Lauren's 0, so that doesn't matter. Now what if I change it to 30? Now my x-coordinate of the rectangle is going to be 20 plus 30. Now what if I want to change this to 100? Now it's going to be 120. So you can see it moving across, right? Now my wheels are still behind, and that's because nothing is being affected by this variable in the ellipses. So if I add Lauren to these, now you can see that they're moving with the car. So I can change Lauren to whatever I want, but because everything's being affected by this variable, they're all moving, which makes variables super, super nice to work with. So now if I increment Lauren, let's make Lauren plus plus. Now the entire car is moving across the screen. Now if I delete this plus Lauren from just 1, you can see that everything except for the circle right here is moving across the screen. And that's because both the rectangle and the circle are being affected by Lauren, the Lauren variable, but not this ellipse. So let me add it back. Okay, so now what if we just want to affect the y coordinates? What if we just want to affect our position this way on the screen? So I'm going to comment out this Lauren. I'm going to restart it. And I'm going to make another variable. And this time I'm going to call it y position equals, and I'm going to call it 20 for now. Actually, I'll start with 0. And I'm just going to add y position to everything in the y direction. Now I'm going to increment y position. See how the car is moving across the screen? Now it can go the same way in the opposite direction. And now you see it coming back up. Right, so then it reaches the top. Now I'm going to go y plus plus again. And it's going to come back down. So there are a lot of things that you can do with this. I'm going to comment this out for now. And this means that you can really move your car anywhere you want. And you can move anything either change its size. You can even change colors. If you look at this here, if I add Y position right now, you can see literally the colors changing because the number is changing in the background, which is really cool. If I add Y position to all of these, our color is going to change a lot. So it really can do a lot of cool things with animation, which is why it's so cool. Now there are a few other things that I'm going to cover in this video. Really, these are the main things here that your students are going to want to learn, just because it's the very basics of animation, but there really is a lot more to learn. So I encourage you to keep looking on things like Khan Academy, on other resources to see what other cool things there are to do with animation, but I'm just going to be showing the basics today. So I showed you here that laren is the same as laren equals laren plus 1. The other thing that you can do is you can do laren plus equals 2, which is the same as saying laren equals laren plus 2. Now, if this is all too complicated and you're getting confused with the laren plus equals and the laren plus plus, and you think your students will also, another thing that you can do is say laren equals laren plus 1. And that's also totally fine. You'll see it totally works. It's still moving across the screen, and it's the same thing as saying laren plus plus. Now, if I wanted to change this to laren plus equals 3, you can see it's going across faster. If I want to change it to laren plus equals or plus 10, super fast. And if I want to change it to 0.2, you can see it's moving super slow. And that's because if it's reprinting every microsecond, if it's only adding 0.2 each time, it's going to be moving a lot slower than if it's adding 10 each time. So I hope that this is a good basis for animation. If you need to know more, I encourage you to watch this video again if you're still confused. I'm just going to quickly review all the things that we covered just so that you can remember them all. I'm going to delete all of these things for now. The first thing is that you need a variable, and again, I encourage you to tell them just to write their name, and I also encourage you to tell them to set it equal to 0. Next, you need a draw equals, and it will autocomplete the function part for you. Then you need a background. You always need a background in here, and that needs to be inside of your draw equals function, or else it won't function properly. I can show you that now just so that you know this is a common error that your students might experience, and you're going to need to fix it for them. So you can see here's my rectangle. So the first thing is I have my name. That's my variable because I want my X position to be affected. Then I have my Y position and my width, and I'm going to make my height also affected by this name variable. So you can see it right here. Since my name is 0, the height is also 0 right now, but that's going to change. And then I'm going to do name plus plus. Okay, so this is what happens whenever you have the background outside. You can see that all this black is happening because every time it's reprinting, the background's not reprinting. So this rect is reprinting, and that's why you can see this rect right here, but the black is also staying because it's getting left behind. Now, if I move the background inside of the function, you can see that the background's reprinting every time. So you're not seeing all the leftover stuff from the rectangle. Okay, and then the last thing that we need to review is the different plus plus things. So I can do name plus plus. I could do name plus equals 2, and then it's going to go faster. Or I can do name equals name plus 2. So I hope that helped, and I hope that you are pretty familiar with animation, because I think it's a really great skill.